Here's 2.4 part 2. Now we're going to go ahead and multiply two complex numbers together. So think of these as foiling using the distributive property. So we're going to multiply 4 times 2 and then 4 times negative 3i. So 4 times 2 is 8. 4 times negative 3i is negative 12i. Then we're going to distribute the 5i to the two terms in the second parentheses. 5i times 2 is 10i. And then 5i times negative 3i is negative 15i squared. Now we have some like terms. These two are like terms. So negative 12i plus 10i is negative 2i. And then do you remember what happens when we have an I squared? What do we do with an I squared? Turns to a negative 1. So some teachers just say, drop the I squared and then change the sign. And you can do that too. I'll just do it for this one. Leave it. So negative 15, negative 1 is a positive 15. And then we combine like terms again. 8 plus 15 is 23. And then minus 2i. Real part, then the imaginary. Let's reduce these complex numbers and put them in standard forms, the real part and then imaginary part. How do I reduce the square root of 9? Some of you might just jump to this, which is fine, and not have that middle step. Square root of 9 is 3. So my real part, then my imaginary. You reduce square root of negative 25 on your own. What do you get? Someone want to share? Alex?
5i.
5i. Do we agree? If you did this middle step, and then the square root of 25 is 5. All right, let's go down to question C. What do I do with the I squared? What? Replace it with a negative 1. Or drop the I squared and change the sign. And then just rewrite it in standard form. So my negative 3 goes first, then my negative 6i. I squared replaces with a negative 1, or drop the I squared and change the sign. Question D has an I cubed. It's either you memorize the pattern or break down I cubed into lower powers. How can I break down it into lower powers? That might help me. Can I go I squared and I squared times I plus I squared Now what do I do with those I squareds? Replace with negative ones. Now combine my like terms of negative 6 times negative 1 is positive 6i, and then negative 1. And then rewrite to standard form, the real part first, then the imaginary. All right, you might see some questions like this in your homework, where we give you an equation, we want you to find out what is the unknown value on either the right or the left side. So think about an equation. An equation balances out the right and the left side. They equal each other. So corresponding parts, the real parts go with the real parts, the imaginary parts go with the imaginary parts. So if I look at this first example, the real part on the left is A. The real part on the right is negative 10. So what must A equal then? If I have to balance it out, the right and the left side, what must A equal then? What would be the value of A? Negative 10. Find the real values for A and B that makes that equation true. On the B value, those are your imaginary parts. So the parts that we set equal to each other are the BI and the 6i. So BI must equal 6i. So what would B equal this in this case? 6. If you want to, you can go ahead and solve that for B by dividing both sides by an I. The i's cancel and you get 6. Or look at it. It's an equation. It's balanced out. I have an I on the right and an I on the left. Then I have a 6 on the right. I must have a 6 on the left. So B equals 6. We'll do one more of these. So we'll set the real parts together and the imaginary parts together. So in this case, A plus 6 corresponds to my real of 6. So A plus 6 must equal 6. So what do we do to solve for that question? Solve for A. So subtract 6, and you get A to be 0. If I substitute 0 in for A, 0 plus 6 would be 6 on the right. Imaginary. Those are your imaginary parts. We want to find out what would be B. So we set the imaginary parts equal to each other and solve for B. How do we solve that equation for B? What do we need to remove from the left side? The I and the 2. So to undo that, we would divide. So the i's will cancel, and I'm left with negative 5 halves. I'm going to stop the recording here.